Hello?
There we are.
Yay! I have to say I'm so embarrassed that you all saw my dirty desktop over there. I usually make a folder called desktop and put everything in it before I give a talk and show off my desktop, but oh well, didn't get a chance to do that today. Yeah, the algorithms of CSS. I'm really excited to give this talk at js.la. I think this is especially a talk that's great for JavaScript developers or people who are, maybe more on the side of JavaScript than CSS to hear. Like Ryan said, I did this talk at CSS Conf EU in Berlin last month in June. And it was very exciting, really fun to be in Berlin. And so I'm giving this talk a version number. So 1.5.2 is this version. So there's some new stuff in here. Anyways, nice whiteboard. So hello, my name is Lara Schenck. And I've been in LA for like a year and a half. It's okay. I'm from the East Coast. We'll see. This is my property on Twitter, LaraS126. Very exciting. And I am a front-end and WordPress developer. Scratch that out for design engineer because I just got a job. I've been freelancing for a while and I got a job and the title is design engineer. And I'm like, okay, like the front-end developer works too, but design engineer, that sounds really cool. Job titles are weird. Okay, so a little bit about my background. So CSS has really been kind of the language that I would relate to most for most of my development career. I started coding like 8 years ago or so in college. I was an art major, and I started learning to build WordPress sites as a way to make money, and that kind of turned into a career that I really love. But CSS and HTML in particular are these really accessible languages that you get really immediate results from, like visual results. So anybody with a visual background probably takes to them really quickly. But there's this kind of weird bias in the industry where it's like, oh, that's not real programming, like, not real coding. So I was like, oh, this is bizarre. But it's not, but it kind of is. So I kind of went on this journey to learn computer science, mainly because I got a pretty major whiteboarding interview. And I was like, oh God, I have to learn to write algorithms now. Wow, this is like sort of relevant to my day-to-day work. So I wanted to bridge this gap between CSS and computer science because as I started learning more computer science, I was like, this is so cool and fun. And like CSS is kind of boring now because I don't have these kind of programming challenges in the same way when I write CSS as I did when I was working on this algorithms in computer science studies. And so throughout this process of connecting computer science and CSS went from like, oh God, I'm writing instructions, this is so boring, to like, whoa, like CSS is unbelievable. It is unbelievable what CSS does. It's so cool that we don't have to do all of that. And so I hope to, in this talk, impart a little bit of that enthusiasm and encourage everybody to kind of peek under the hood a little bit and see what CSS is really doing. Okay, so I started out my research with this question. Is CSS a programming language? Followed up with a fire emoji, because that's definitely a hot topic, or definitely elicits a lot of like gut responses from people like, yes, no. So I asked this question on Twitter and got a variety of responses. So we have 42% yes, it's a programming language, 50% no, and 8% I'm not sure. And this was really interesting because the yeses were like, yes, absolutely, like yes, CSS is a programming language. And the no's were like, no, I don't list it in my list of languages, or like, no, I don't really see it as a programming language, kind of more opinion based. And I was like, okay, let's stop, like what's going on here? Why is there this weird discrepancy, like such a polar discrepancy? And so I was like, what is a programming language? It turns out, a programming language, the many definitions I've read, and I did a good bit of research about this, it's a language of instructions for a computer. It is kind of paraphrasing Wikipedia and others, but there are a few really pointed good blog posts about what a programming language is and how we define a programming language. In the world of computer science, it's important for that definition to be really broad because programming is really a language of instructions for a computer, and how those instructions are formatted can vary greatly. So that kind of brings us to programming paradigms. How many of you out here are familiar with programming paradigms? Okay, a few people. Yeah, so these two words in particular should probably be familiar-ish. But a programming paradigm is, in general, a category or a model for how a programming language works or how a program is written. So they're kind of big picture categories or paradigms, so not necessarily super specific. So imperative is kind of a very big one, and then declarative, and those are like the two umbrella paradigms. So you can kind of dig into each of those more either way. So imperative is how. So when we have an imperative programming language, we're telling a computer how to do something, and a declarative language tells a computer what to do. And the main difference there is the presence of control flow in an imperative language and no control flow in a declarative language. So what control flow means is you're kind of controlling the execution of statements, the execution order of statements. So in an imperative language, a program is read top to bottom, and you might be jumping all around in order the execution order of the statements. And in a declarative language, that execution and that logic is more baked into individual commands. So you might just say, like, do this, and it's doing a whole bunch of things, but you're really just giving it that one instruction. So what kind of languages fall into these categories? Imperative languages are what we usually think of, so JavaScript, Ruby, C++, Python, etc. And declarative languages are often domain-specific. SQL is a domain-specific declarative language for databases. HTML, okay, is a domain-specific declarative programming language. And of course, our beloved CSS falls under this category. All right, there we go. Yeah, I was like, oh my God, yes, I did it. Like, I proved it. Like, okay, and so instructions for a computer, like, okay, got it. Obviously, they're very, like, writing Python and writing CSS are very different, but I think they can be, I don't know, there's a lot of interesting things that come from looking at them under the same lens. So CSS further is Turing complete. CSS plus HTML. Turing complete refers to the ability to simulate a Turing machine, which is the ability to compute a problem of a certain complexity. And CSS and HTML can do that together. CSS has math. There's a calc function. It has functions and variables. And so it's like, what's going on? Why isn't it a programming language? So I would ask, like, why not? Yeah, there's a lot of differences, and it is this domain-specific language, and domain-specific languages in general are a really different topic. But why not? The web is declarative in a lot of ways, so we have a lot of power in telling a computer what to do instead of how to do it. Like, a lot of APIs are written in declarative fashion. So CSS is a domain-specific declarative programming language. 100%. Okay, it's a little bit of a mouthful, and it's like, well, you gotta include that declarative domain-specific part, otherwise it sounds weird. CSS developers program the layout of web pages. More like boxes, though. So if we like dig into it, it's like, oh, programmers of boxes. Like, I like that. But then if you think about how a browser really works, and it's like, they kind of all become images after a while. So give that 100%. And with that in mind, we're going to do browser internals in less than 5 minutes. This is a new part of the talk. I'm going to try to just zip through it, because it's important to have this background and this mental model for how a browser works. How many people have taken the time to really look into the inner workings of a browser? Okay, a few people. Good. Yeah, this really changed the way I did everything. It's kind of funny, like, you can write code and build websites and not necessarily understand how a browser works. That's how, like, abstracted our tools are from what they actually work with, from the domain, so to speak. So, okay, here's me on the computer, obviously. And there's a server, obviously. And when I use the computer, I'm like, okay, server, like, typing in the browser, give me data. And the server's like, okay, here is data. Great, okay, bye, we're done. Yeah, so some words. Client, server, HTTP request, and that response from a server is given in bytes. And those are bytes of HTML, CSS, and JavaScript code. So if we go inside the browser, we take those bytes, and those bytes are parsed into tokens. And so if you kind of picture all these bytes, which stand for certain letters, and then the parser looks for certain combinations of characters, and then assigns meaning to those characters in the form of tokens. And as it's going through those tokens, it's saying, like, oh, is this HTML? Is this CSS? Is this JavaScript? And it turns those into trees. So we have the DOM, beloved DOM, and there's also CSS OM, which is the tree representation of styles. And that information is then taken and turned into a different tree, which is the render tree or the style rule tree. And this rule tree is essentially a list of instructions for laying out a browser web page. I am totally skipping JavaScript, FYI, in this description of a browser. Algorithms of CSS, come on. So that render tree is kind of a blueprint of instructions for laying out a web page and laying out all these boxes. And the layout process in a browser, if you've ever heard of reflow, that refers to triggering this layout process. It's like a recursive process for laying out all of these boxes based on the instructions in the render tree. Then all those boxes are painted, and so they become images. So it's kind of like a bunch of little images laid out on top of each other. And then there's the composite step, where there's a certain set of CSS properties that are applied after paint, and everything is kind of composited into one big image, which is then rendered onto the browser, or rather rendered onto your computer. So rendering, yay! So CSS is a domain-specific language to program like this rendering process. That's kind of how I like to look at it. Okay, switching gears slightly to algorithms. Yay! I like drawing these little monsters. There's a couple of them in here. Okay, so algorithms, another definition. A well-defined computational procedure that takes input and produces output. Has anybody read, well, if you've read it in its entirety, that's amazing. But Thomas Corman has this Introduction to Algorithms book that's kind of the canonical textbook assigned in intro computer science classes. But I recommend looking it up. It's a little dense, but it's definitely a comprehensive overview of algorithms. So if we take that definition and put that in a little framework, we've got inputs and we've got outputs. Input, sorting. Sorting is a great use for algorithms. So we've got an unsorted list. Output is going to be a sorted list. What happens in the middle? Well, let's hear, who can name a sorting algorithm?
Merge sort.
Merge sort. Oh, whoops, bubble sorts first. What was that one? Lazy sort. Oh, that sounds like my kind of sorting algorithm. Select, I'm not actually lazy, everyone, but selection sort, bubble sort, merge sort, quick sort. Okay, yeah, these are all solutions to the sorting problem. Cool. Let's look at an implementation of bubble sort. Cool. Wow, bubble sort in all its glory. So for anybody who's not familiar, bubble sort is kind of known as like a really slow sorting algorithm. But it's a good intro to algorithms kind of thing. So this is imperative JavaScript. This is imperative code. So the computer is going to read this program and kind of jump around between statements. There's a for loop, so it's going to jump back up to execute certain code. I'll give it a heart, because we like JavaScript, of course. So if this was declarative code, if I wanted to do declarative bubble sort, all of this would be hidden somewhere, and I would just say like bubble sort, basically. Okay. Let's look at another framework. Oh wow, you think that's funny, huh? Bubble sort. So good. Okay, let's have another algorithm. Input, a tall stack of boxes. Oh, see where this is going. Output, a row of boxes. What's in the middle? Display flex, perhaps? Float left? Gasp! Floats still have their place, my friends. Okay, let's take a look at the implementation of display flex. Groundbreaking! Display, wow! That's a declarative CSS. That's so cool. I love it. Okay, so what's happening under the hood here? Like, what is display flex? I'll show you a very tiny piece of display flex in a moment. So this is the difference between kind of declarative code and imperative code. Declarative was what you see on the top, and there's this whole like huge backing of imperative code underneath. So for CSS, that declarative part is the browser, or rather the tip of the iceberg. And then underneath we have C++ or Rust code. So this is the source code of a browser. And I spent a really long time looking through browser source code. And it's really fun, actually, especially after I had this kind of algorithms background knowledge. I was like, this is really addicting to take what I know really well, CSS, and map it to the browser and what's under the hood. Okay, so this is a little bit of Rust code from the source of Servo, which is the browser engine in Firefox Quantum. You can read this if you want to. Flex wrap maybe is my comment. I'm not sure if this is actually flex wrap, but this is a little tiny snippet of the probably thousands of lines that make up what Flexbox does. And we don't have to write this. That's pretty awesome. Imperative Rust, love it. Firefox. Okay, so what? Okay, yeah, I knew there was some kind of browser code that was happening under the hood of CSS, obviously. So this is when I learned this and started thinking about this as I was reading CSS, this is when CSS went from oh God, instructions boring to whoa, what is this doing? There is so much computer science all over CSS. And when you start to think about it, it's oh, this is incredible. I love it. Okay, let's take a look at another algorithm. Does anybody know what this one might be? The Cascade. Who loves the Cascade? Okay, a couple people, cool. Who strongly dislikes the Cascade? Less people. Cool, I like it. I feel like the Cascade gets a lot of flack because it can be a real gotcha for people starting to learn CSS, and it's something very unique to the domain of CSS. So let's look at the Cascade as an algorithm because that's what it is. An algorithm that combines property values from different sources. So that's from Mozilla Developer Network. This is also the first thing that comes up when you Google algorithms and CSS. Maybe my talk will come up now, but this is really. Little background too, because we're gonna use some terms here. In CSS, the different components, kind of the grammar, so to speak, of CSS as a language is very specific names. So a selector is what you're selecting in order to style. So that could be your class, or it could even be a pseudo element, a general selector. And then we have property and value. And those together are called a declaration. And then the whole thing is called a rule or a rule set. So I think it's important to use these terms really intentionally. And that's what everything's referred to as in the source of a browser and in the spec. So it helps a lot to use those terms. Algorithm of the Cascade. Value. Okay, input. We have our array of values that are collected from various areas. Output, it's essentially a sorted array of those values, or not an array per se, but a sorted list of those values. So the Cascade takes these values from different areas. So if you have a paragraph that has a style from the browser and then a style from various areas, it's going to combine them. And then we have some steps in there. And the steps are sorting by importance and origin, specificity, and the order specified. Cool, you get a winner. Not going to go on too much about that because you can read the spec, and that's going through algorithms step by step. It's not that exciting. So I was okay, I want to look at this in the browser, Cascade, magic. This is what I expected to find. I was function, Cascade, magic. And guess what I found? Function, Cascade. I was wow. So this is probably not the actual, the real Cascade. There's many definitions of the Cascade throughout the source code, but I was this is a fun slide, cool. So where do you see this if you want to kind of peek under the hood and take a look into a browser? Searchfox.org has the source code of Firefox. And then chromium.org, cschromium.org, is the open source rendering engine called Blink, which is a fork of WebKit. And that is written in C++, which I found a little more difficult to look around, and it's also a much older code base. So my process here was to kind of go back and forth between the spec of something and then see if I can find that implementation in the source code, which is pretty cool. And let's take a look at the Cascade in the browser, so in the inspector. And I'll go through this quickly, because I'm sure we've probably used the inspector before, or DevTools. So here are some declarations and some rule sets. And we can see this one value is kind of the winning value. So that's the one that's not crossed out. Links are a good example of this, because a lot of times there's several styles that are applying to a link. Then we can also hit computed here. So the computed tab will show us a little different view that's based on all the properties. So rather than showing you the rule sets, you can look at the computed view to see different properties and values. And that'll show us everything that is sorted here. So this is kind of that other side of the spectrum, that sorted list in the output. And also notice this RGB value. So the value that was defined in the style sheet was a hex code. And this is showing us a computed value of RGB. So one other step in rendering is that all of these values that we write, a lot of the values in CSS that we write are for our purpose. So like percentages or viewport units, those are for us to read. And the browser has to ultimately turn everything into pixels and RGB, which is kind of interesting. We can also look at this browser styles checkbox here, and that'll kind of show us that indeed every property does have a value. So it's kind of an interesting concept. So you can always like reset properties back to their original values. Okay. So I want to have a little story here of writing CSS. This was a beautiful mock-up that I got from an agency I was working with a little bit ago. So it was like the mobile mock. This is a drawing of the mock, obviously. Hopefully that was obvious. But there's this beautiful ocean on top. And I was like, okay, cool. Like, yeah, we can split this up into 2 images. This like high-res ocean thing, and then the bottom one will be a little transparent PNG, but it'll be a PNG, so it's a little smaller. I was like, okay, this sounds great. So I started writing it. Started writing the code, coding up the layout. And I was like, oh my God, these are completely different aspect ratios. So like, oops. So over here, it's like, oh, they're totally different. Like this is not working. I'm having to do some weird, annoying positioning stuff. So I started writing CSS with a hammer, which is what kind of the default is. You're like, keep trying things. And you're like, oh my God, just work. Like, keep trying stuff over and over and over again. And eventually it'll work, right? Yeah, probably. You'll probably figure it out eventually. And then the next person that has to read it, it's going to be like, what is going on? So that's, we do this with more languages than just CSS for sure. But I would say no. I was like, no, I'm not going to write CSS with a hammer right now. I'm doing all this research about algorithms and like CSS as a programming language. Why don't I like break down this problem into like an algorithm? Why not? So I kind of thought about this framework and I was like, what are my inputs? Are these couple images in a device, and outputs are my programmed images, my programmed boxes sitting together perfectly. So I was like, okay, what would that look like? How do you write an algorithm? And I was like, well, I've been studying for this damn whiteboarding interview. And there's like a defined process for how to write algorithms in a whiteboarding interview. So first you plan out your algorithm, then you come up with a brute force solution, and then you walk through it, and then you optimize your solution. So I was like, what would this look like if I was applying this process to CSS? So I started by planning it out. So think about how I want these boxes to respond at each device size. And it's so important to like bake in responsive design from the get-go. Like as soon as you start writing CSS, be resizing your browser all the time. And then, map it out a little bit. So the more I've started thinking about CSS like this, the more I like use pen and paper and map out some values. I'm thinking about it algorithmically a little bit more. And I would write some pseudocode CSS, sure. And this eventually can kind of become my styles, and I change it a bunch. But then brute force solution, AKA spaghetti. Yeah, that's fine. Like we're allowed to write bad code. That's okay. So I have my brute force CSS, smelly CSS. What are some qualities of brute force CSS? Part of a system? No, definitely not. Magic numbers? Absolutely. Do I have a bunch of hard-coded pixel values? For sure. To-do comments everywhere? Also absolutely. Does it work? Maybe a little bit. Cool. Like it's just your time to like, play around, figure out what you're looking for, try to get it to work. And then my walkthrough step. So is this like resizing the browser all the time? I'm sure a lot of us do this, and it's like, I'm not sure if users do that, but I do, so it's gotta work. And then optimization. So our optimize step, which also includes refactoring. So kind of over and over and over again. Wow, you like that over there laughing. Okay, so we take our smelly CSS and transform it into a beautiful flower. Of course, that's how code optimization works, right? What are some qualities of optimized CSS? Part of a system, yes. So how many of you work within a design system or some kind of component architecture? Okay, that's a good number of hands. I personally, when I've done this, I find it so hard to write new CSS with that architecture in mind. So my strategy now is to kind of just like write the crap CSS, get it working, and then be like, okay, how can I incorporate this into my system? What change do I need to add a new component or a new whatever? But get it working first, then think about all this stuff. Does it use algorithms? So does it use algorithms like Flexbox, Grid? CSS Grid has a ton of amazing algorithms. Intentional Cascade. So the Cascade can be some pretty incredible, like baked-in declarative logic, and especially in terms of browser support. So try to embrace that. To-do comments? Probably some of them still, but get rid of a lot of them. Okay, and I'll do this slide just to kind of show some of my favorite optimized CSS things. So custom properties plus the var function. I would love to do another talk about that. Game changer with CSS, custom properties, amazing. Per component grid layouts. CSS Grid, if you haven't spent an hour something, go to CSS Grid Garden and do the exercises. It's amazing, it's so fun. Calc, math is great. Flexbox, yay! Transforms and positioning. Transforms are incredibly performant properties to animate, they're great. Viewport height and width, aspect ratios, less media queries, yay, hearts for everything. Okay, yellow light. I want to show a couple algorithms here as we're finishing out. This is the algorithm for my wonderful ocean. So I'm not sure if everybody can see this. This may or may not have a pointer. Oh, yay. Okay, so setting some custom properties at the top, so like setting up some values. Some pretty cool CSS Grid stuff going on. This property is going to be adjusted in a media query that is not present on the slide, etc. So very intentional code that kind of took a while to fine tune. This is some centering code here. So the oldest trick in the book for centering is kind of center and then use a transform to go up 50%, which is what this push value would be. Another photo strip. These slides will be posted later. Magic, maybe. Okay, and then my favorite algorithm. Yeah! FizzBuzz in CSS, no problem. Absolutely, okay, cool. So, back to the kind of higher level thinking here of what we can do with algorithms in CSS and like algorithmic thinking about CSS. I think this can really help to smooth out that design to development workflow and can be a conversation starter between designers. So if we have our wonderful designer and developer here, of course, unfortunately this process is not all puppies and kittens, but we can pretend it is here. Talk about algorithms together, yay. Or maybe have a designer / developer. You can talk about algorithms with yourself. Can help smooth things out a little bit. It can be a nice conversation piece. So inputs. Inputs are your design. So are your designs mock-ups? Sure. Is it on a napkin? Maybe, that's cool. That's an input. Is it a little mock-up of a component? Also an input. And the output is going to be your rendered code. So responsive on all device sizes. And what's the algorithm in there? So design systems and component libraries, like absolutely at a high level, the combination of different components can be thought of as algorithms. Your CSS, so any CSS you write. Yes. Okay. Yeah. That's kind of be my favorite. It's cute. Okay, conclusion. Let's try this, I don't know, maybe not write CSS with a hammer as much. But I found when I started thinking about CSS as programming, I was like, okay, I'm gonna approach these problems with a whiteboard a little more, like spend 10 minutes and like draw out the widths and heights of things and see if you can kind of come up with a more thought out solution rather than that spur of the moment, like just banging out instructions. And also the biggest takeaway of this whole process is like the code we write, and this applies across the board, especially in the JavaScript land of frameworks. Like the code we write is oftentimes kind of the tip of the iceberg, and our kind of mission as developers, I think, is to fill in like the bottom part with what we're learning. So kind of learn inch by inch what makes our code work. Also had this idea for a cool, really annoying app called the Mindful CSS Bell. So it can go off like every 30 minutes and be like, read the spec. Like, do you actually know what this is doing? Read the spec. This is cool. Doesn't that sound like a great app? I could definitely use that for JavaScript too, any programming language. So at the end of the day, did I bridge this gap between CSS and computer science? Well, I kind of figured out it's more like a big grassy area of little pools. So they're all part of one thing. So CSS, C++, HTML, JavaScript, computer science is a very broad spectrum that this is all part of. And I also want to just mention this talk quickly by someone named Felian, who did a talk called What is Programming Anyway? And she talks about her journey as a computer scientist. She was researching domain-specific languages and like, what is programming? And there's this notion of like, that's not real programming. And that's a weird thing in the tech community, to have someone who's like really excited about something to be turned away by their community. So I think that's just something to keep in mind. And like maybe like math and engineering aren't the only metaphors in ways we can talk about what we do. So she, in this talk, talks about how programming is writing and uses writing as a metaphor for writing programs, which I think is really beautiful. And she also draws her slides. And I was like, what? So other people do this? This is great. So above all, like, why not? So I don't know, like CSS, it's great. I'm a little monster. And thank you all so much.